In this lesson, we are going to be working on solving logarithmic equations.
One of the most popular choices by parents in the Bay Area is Tutoringisus. We offer college advising, tutoring services, SAT and ACT test prep all under one roof. Where hard work achieves dreams, Tutoringisus is here to help.
Let's start with problem number 21. It is the natural log 4x minus 7 equals to the natural log of x plus 11. We could say that to get rid of the natural log, we raise both sides to the e, and that will get rid of the logs. But we also, since there's a natural log over here, natural log over here, we could just take the quantities and make them equal to each other. So however you like, it would be the same. I just move my 7 to the other side. I have 4x equal to x plus 18 minus x minus x. 3x equals to 18. Divide by 3 by 3. And x equal to 6. For a log function, natural log or any log function, we need to go back and make sure that we are not going to get something that does not make any sense. As we know that logs cannot be zero or negatives. So the values of logs always have to be x greater than 0. And if we go ahead and try to substitute x equal to 6 here, we see that it is quite a bit far from conversion to a negative. So the solution is fine. Problem number 23. We have log base 2, 3x minus 4 equals to log base 2 of 5. Again, we could raise this to the 2 and to the 2. This cancels, or we could just grab them since they are to the same base. 3x minus 4 equal to 5 plus 4 plus 4. 3x equals to 9. I divide by 3, and x equals to 3. Let's make sure that this makes sense. So if I go ahead and substitute 3 for x, that's going to give me 9 minus 4 is 5, and anything else is north of that. It's not going to make a difference because this part is constant. So my solution is correct and holds. Problem number 25. Log base 2 4x plus 8 equals to 5. Now I don't have a log on the other side. So to get rid of my log and open up this quantity right here, I need to use the inverse property of the log, which is raising it to the same base. So if I raise this to the 2 and raise this to the 2, this cancels out, and now I have 4x plus 8 equals to 2 to the 5, minus 8 here, and minus 8 here. So now I have 4x equals to 32 minus 8. That is 24, and 4x, and divide by 4, and x equals to 6. I go back to my equation to make sure that my solution works. Everything is positive here, so there's nothing can go wrong. My solution holds. Problem number 27. Log base 7, 4x plus 9 equals to 2. I need to open up this quantity. That means I need to get rid of my log. I raise this to the same base, which is 7, and I will do the same thing over here. This cancels out. Now I have 4x plus 9 equal to 7 squared. I subtract 9 from here, and I subtract 9 from here. And now I have 4x equals to 49 minus 9. 4x equals to 40. Divide by 4, and x is equal to 10. That's my solution, and I just want to make sure that it holds. I go back to my equation, and I see everything is positive. So everything is going to go toward the positive, so my solution holds. There's no restrictions. Problem number 29. Log base 10, 12x minus 9 equals to log base 10, 3x. This is known as a common log, and that's why I said it's log base 10. So now again, I could raise this to the 10, and raise this 10 is not going to make a difference because I have the same logs on both sides. So this quantity will equal this quantity. So now I have 12x minus 9 equal to 3x. And I'll move my x that side, and I'll move my 9 to this side. 12x minus 3 is positive 9x equals to 9 divided by 9 by 9, and x equals to 1 as a solution. Now I go up and check for validity, and I see that if I put x equal to 1, that would be 12 times 1 is 12, minus 9 is 3, and so on. So my solution holds. Problem 31. Log base 2, x squared minus x minus 6 equals to 2. I don't have a log on the other side, so I need to use the inverse property, which is raising this to the same base. That cancels out, and now I have x squared minus x minus 6 equals to 2 squared, which is 4, and I'm going to bring the 4 inside because I have to factor this equation. Minus 6 minus 4 equal to 0, and I have x squared minus x minus 10 equal to 0. Since this cannot be factored, then I'm going to go ahead and use either the quadratic equation or completing the square. In this case, I'm just going to go ahead and complete the square. This would be x squared minus x plus 1/4 equals to 10 plus 1/4. This will factor out to x minus 1/2 squared equals to 10.25. Then I'll take the square root of both sides, and I end up with x minus 1/2 equals to plus or minus the square root of 10.25. Move the 1/2 to the other side, and I will have x equals to 1/2 plus or minus square root of 10.25. If you put that in the calculator, I came up with x equal to 3.7 and x equal to negative 2.7. Now, and plug these values back into our original log equation, both solutions would work. The first positive one would work, and the second, because we have the squared and the negative times the negative, is going to give us a positive. Both solution would work. Problem number 31. We have log base 2 of x squared minus x minus 6 equals to 2. There's no log here, so I have to raise this to the same base. It'll be to the 2 here. This cancels out. Now I have x squared minus x minus 6 equals to 2 squared. That will be 4, and I'm going to bring it inside. So I'm going to do minus 4. So this is going to give me x squared minus x minus 6 minus 4 equal to 0. And it will be x squared minus x minus 10 equal to 0. Now, in order for me to solve for x, I have to factor this equation. Well, I can see that this equation is not factorable, so either I have to use either completing the square or use the quadratic equation. I'm going to go ahead and complete the square. Completing the square is going to be x squared minus x plus, that will be a negative 1 over 2 squared will be 1/4, and moving the 10 to the other side is going to be 10 plus 1/4. If I take the factor of this, is going to be a perfect squared. X minus 1/2 squared is going to equal to 10 plus 1/4, which is 10.25. To solve this, I have to square root this side, and I have to square root this side, and this becomes plus or minus. So now I will have x equals to 1/2 plus or minus the square root of 10.25. And if you munch this in your calculator, you're going to end up with x equals to 3.7 and x equals to negative 2.7. All right, now I have to go back and make sure that none of this will violate the rules of logarithm. So if I put the negative here, that's going to be I don't worry about the positive, because once I square it, it's going to give me a big number. And I worry about the negative, so if I look at that, that's going to give me a big number, and that is going to change to positive, so I'm fine. So these two hold. You could do a little bit more detailed work yourself if you'd like. At this time, we're going to solve the equations, and we're also going to check for the solutions and make sure that would not violate the log rules. We will be working on the odd problems. We'll do 33, 35, 37, and 39. We'll start. I have log base 2 of x plus log base 2 of x minus 2 equals to 3. Since I have an addition here, I need to use the property of logarithms, which converts this to a multiplication. So this will be log base 2 x times x minus 2 equals to 3. Now I raise this to base 2, and this is to base 2, and I'm going to end up with x times x minus 2. 2 to the 3 is 8. Open this up. I'm going to minus 2x. I'm going to bring my 8 inside. It's going to be negative 8 equal to 0. And now I can factor this. This will be x minus 4 and x plus 2 equal to 0. I will use the zero product property, and this will give me x equal to 4, and this one will give me x equal to negative 2. And now I need to go back and check. So in my equation here, this is, if I have a negative 2, either this or this, they're both going to be turned to negatives, and that's not acceptable. So this would not hold. My solution will be just x equal to 4. Problem 35. Natural log of x plus natural log of x plus 3 equals to 4. Again, I'm going to use the product property rule, which will give me natural log of x times x plus 3 equals to 4. And I'm going to raise this to the e. So both of these to the e, and now I'm going to end up with x squared plus 3x equals e to the 4. And I'm going to bring this inside, and I'm going to solve this. Minus e to the 4, which is 54.6. So I'm just going to change e to the 4 to 54.6 equal to 0. And we will use the quadratic equation to find the solution. And once you do that, you're going to end up with two numbers. X equals to 6.04 and x equals to negative 9.04. As you see, if you put the x equivalent to 6.04, we're going to get positive, and we're going to get positive here. Everything is good. So this is for sure is a solution. For the negative, unfortunately, it is not, because if you put a negative here or here, we're going to end up with a negative, so this is not. Problem number 37, log base 3, 3x squared plus log base 3 of 3 equals to 2. So we're going to go ahead and use the product property. That's going to be log base 3, 3x squared times 3 is equal to 2. We will raise this to the same base, and we're going to end up with 9x squared equals to 9. We divide by 9, divide by 9. We're going to end up with x squared equal to 1, which gives us x equal to plus or minus 1. Now we need to go back and see which one of these solutions work. So if we put positive 1, that would be fine because it's x squared. And also if you put a negative 1, that would be fine. So the solution would be x equal to plus 1 and x is equal to negative 1. Both of them hold. Problem number 39. I have log base 3 of x minus 9 plus log base 3 of x minus 3 equals to 2. I'm going to use the product property. That becomes log base 3 of x minus 9 times x minus 3 equals to 2. I'm going to raise this to the base of 3, and so is this. This cancels out, and now I have x minus 9 times x minus 3 is going to equal to 3 squared, which is 9. I'm going to open this up because I need to put this inside and make it equal to 0 to solve. So that's going to give me x squared minus 12x plus 27 equals to 9. I'm going to bring my 9 inside, minus 9, and I'm going to end up with x squared minus 12x plus 18 equal to 0. This is not going to be factorable. I'm going to go ahead and complete the square. So if I complete the square, I'm going to get x squared minus 12x plus 36. And my 18 goes to the other side, so it's going to be a negative 18. And I'm going to add 6 squared, which is the 36, to it. So that's going to give me 18 positive, and that's going to be x minus 6 squared. And if I do the square root, then I'm going to end up with x and solve for, move 6 to the other side. I'm going to end up with 6 plus or minus square root of 18. And if I do the calculator stuff, then I'm going to end up with x equals to 10.24 and x equals to 1.8. I'll go ahead and check my first value, which is a 10.24. In here, it's great because 10.24 higher than a 9. I will have a positive here. I'm okay. If I come over here, I only have a negative 3, and this is a 10, so I am also okay. So this is a solution for sure. Let's check the other one, the x 1.8. Aha. If I put 1.8 minus 9, I'm going to end up with a negative. So right away, we don't even have to check the second one. This is not applicable. So my solution is just x equal to 10.24.
One of the most popular choices by parents in the Bay Area is Tutoringisus. We offer college advising, tutoring services, SAT and ACT test prep all under one roof. Where hard work achieves dreams, Tutoringisus is here to help.